Hello, everyone. It's Jianying from Nuclei. So glad to be here. Yeah, it's our second time to be North American RISC-V Summit. Yeah, today actually I'm on the stage is a little bit nervous. I'm nervous is not because my English is not good as my Mandarin, right? Because it's very obvious. I'm nervous is that RISC-V ecosystem is going so fast. I'm nervous is what we have done in the past 12 months is not fast enough. So today I will elaborate what we have done in the past 12 months, especially on the function safety and the security stuff in automotive segment. As we have many partners and friends entering RISC-V every year, so I will give a brief introduction of our company, Nuclei. Nuclei is a company founded in 2018. Our focus is on the RISC-V IP and the RISC-V CPU subsystem. Our headquarters is based in Shanghai, China. We have around 120 employees, and the majority of them are R&D engineers. Unfortunately, we don't have a physical site out of China, but we can support worldwide business through the online documentation system and a Jira ticket system. We have built our RISC-V CPU IP portfolio from scratch. Over the 6 years, we have over 250 customers, covering 5G communication, industrial, AI, automotive, IoT, etc. Here are some reference logos. Most of them are China domestic logos, but some of them are big ones, like Giga Device, China Mobile, Verisilic, Logic, etc. I think they have many worldwide products. And also very glad we see more and more global customers are engaging with us from other regions. Here are our current RISC-V CPU IP portfolio. We have the NX, UX classes for the 4 general product lines. And also we have the NS, NA, and the NI, 3 vertical product lines. NS stands for Nuclei Security, and NA stands for Nuclei Automotive, and NI is for the Nuclei Intelligence. Based on the performance or the pipeline stages, we divided to the 1000, line 6, 3 to 100 series. So the 1000 series we just announced this March. This is our first out-of-order core with the configurations 3, 4, 6 wide dispatches. And our popular series is the line 100 series. This is the line stage dual issue in pipeline architecture and with a lot of configurations. And for the 600, this is the 6-stage one issue, the one issue in order architecture, and the others are just 2 or 3 pipeline stages for deep embedded processors. So today, I will focus more on the automotive series. For the NA 900 and the 300, both of them got the ISO 26262 ASIL-D product certificate. Both of them got the systematic capability and the hardware capability on the ASIL-D level. And right now, we are also working on the STL ASIL-B certificate as well. Yeah, it took so much effort of our team to get to here. Yeah, it's not easy. This is the overall diagram of the NA series. A lot of other features and blocks, but the major security features includes the dual clock step, the total self-check comparator, the ECC protection on SRAM, the I/O parity protection, and the external watchdog stuff. I think this picture shows clearly about the differences between the ASIL-B and the ASIL-D. Because I think the major metrics for the ASIL are the SPFM and the LFM. For ASIL-B, SPFM is about 90% and LFM is about 60%. But for ASIL-D, both of them needs to about 99% and 90% respectively. So for ASIL-B, we have implemented the SRAM ECC stuff and also the parity check on the key register. In addition, for ASIL-B, STL, the soft test library is a must. But for ASIL-D, all the costs on the hardware side. Besides the ECC on SRAM and the parity check on I/O stuff, the major part is the dual clock step. So here we show the details how we implement dual clock step. On the top side, the traditional dual clock step just duplicate the logic part and share one copy of the memories, including the SRAM and the cache stuff. But we noticed in the latest ARM, R52 Plus, right, they have implemented the trouble core lockstep. But we talked to a lot of customers. That hasn't been acknowledged positively by them up to today. Because if they want to higher safety level, they want to do more things on the SoC level, not just the core level. So we will keep eyes on that. Whether we need to catch up from dual clock step to trap core or dual core is enough. In case some of the scenarios, just one chip needs to be applied to different applications for both ASIL-D and ASIL-B, we implement the split mode, I think, on the bottom side, duplicate the logic stuff, and also add one more copy of the memory in the green side. That can be configurable easily through software. The chip or the product can be used easily from switching from ASIL-D to two split ASIL-B cores for higher performance. There's some of those real scenarios from the customer or the market. But for ASIL-B, I mentioned it's easily to be implemented on the hardware side, but it's quite challenging on the software side. I think the STL development takes a lot efforts. It needs a lot of iterations, back and forth iterations from safety analysis to the fault simulation and FMINTIA report analysis, and we do the STL controller and the STL soft development cycling and cycling. Later, I will show the number, how the coverage we can achieve just by STL only. This is the example of our function safety package. It's mainly conclude FMINTIA report and the safety manual. I think the safety manual is a key for the customers. It includes the SEOC, safety mechanism architecture, the assumption of use case of safety, and also the safety integration stuff. Here are some numbers. Maybe it's too small. Here I think, let me try. Which one? I'm sure the bullets, no? Oh, sorry. I think on the top line, it shows the hardware cost of ASIL-D. So it's basically double of the logical area, 2.1x, just a double. It's a little bit complicated for the ASIL-B on the bottom side. If we don't add any additional hardware, so it's just achieved diagnostic coverage around 60 to 65% by STL only. If we implement the additional STL controller, add more watch point stuff, it can achieve 55% to 80%. The hardware cost is about 3 to 5% of the logic part. Definitely, it cannot be claimed it's fully compliant for ASIL-B. But if we include SRAM, it's fine. It can be easily to increase the coverage over 90%. Yeah, and that's why I think for the function safety stuff, we need to consider the logic part and the SRAM together. This is another IP, I think, the HSM stuff, the hardware safety module, because security is required more and more in automotive. For the data security and the processing, whatever. We also developed the HSM standalone IP. Besides a configurable RISC-V core in the bottom diagram, and along with the synchronized and asynchronized encryptable IPs, and also we provide the whole software stack, including secure boot, procedural boot room, even the host computer tools stuff. Yeah, right now, this IP can achieve eVita 4 level. And also, we are working on more side channel protection features. We will enhance the security standard on this IP more and more. Also, it has been adapted by, I think, around 5 or 6 more customers along with our NA series. The RISC-V cores. Up to today, we have around over 15 official automotive customers. I think the number is going today because probably this week I'm in US. We have a new contract coming. I think it's good news for automotive. It's good to see the customers are covering safety island in ADAS and the radar, UWB, the MCU, engine ECU, Ethernet gateway, and all the applications. And on the right side is just one of the example, the engine ECU, have our 2 NA dual-core lockstep cores and our standalone HSM subsystem. Yeah, if you guys are interested, actually we bring a chip here. This one of our customer surgery, and it's taped out, and 40 nanometer, running 300 megahertz with our 3 lockstep core, and it can be split to 6. So if you are interested, please come to our booth. Yeah. Look at all of those automotive applications. I think we are so applaud what we have done in automotive. We get the classic Autosa OS supported, and the certificated compilers and the tool chains from the partners, and also the safety autos is supported. I think a lot of contributions and achievements by the whole ecosystem. Definitely, we have received a lot of challenges or concerns from Tier 1 and OEM. Once we go faster. Right now, the QNX OS is not support yet. We have a lot of discussions with QNX, and they still have no way to go there. And also the software transfer cost offer is not just a minimum, so the customers still have some concerns. And also, I think for our standardization, especially for the debug and the trace, it's kind of a behand. Our chip is available, but our E-trace and N-trace specification just finalized yet. We have a lot of, the discussion with IAR, Lauterbach, and others. Even we implement the on-chip trace solution adopted by our customers. But right now, we need more ecosystem partners to have more options for our customer. Another serious issue bring up is about the compiler. We have some of the compilers certificated by the partners, but the certificated version is not great as the version for ARM, because we need a better balance for both performance and code size. Right now, you choose better performance, you will sacrifice the code size. You will choose better code size, you will sacrifice performance. So we are still working on that with the customer and the ecosystem partner. And great to see the previous speech, because virtualization is a serious aspect for our customers to adapt. I think non-MMU virtualization running for multi-OS is a trend for, is a must for automotive. So glad to see that we have progress. I think we can work together to see the further progress. So quick wrap, NA3 has large configurations to fit various automotive SoC requirements. We provide both ASIL-B and ASIL-D solutions with comprehensive safety package, including FMedia, FEMA, and other stuff. I think and also believe automotive is a growing and a promising segment for RISC-V, even for ARM. But now it's a beginning stage. That's why we're looking forward to working with all the customers and the partners together to promote, to accelerate RISC-V ecosystem in automotive application. So please come to our booth to check out all the details. I think thank you all for the time and for the attention. Enjoy your lunch. Thank you.